All right, good morning, everybody.
Morning. Morning. Good morning.
All right, so I posted a new ODP, which I don't necessarily expect people know how to do yet, so we're going to go over in class what you need to know to do ODP 408, which is due tomorrow morning at 10. So that's going to be our main thing today, is talking about command line arguments from C programs. But any questions before we start on that?
I do.
Go for it.
I was messing around with scanf and ARGC yesterday, and I was trying to get an integer, but if I just clicked enter, it would just spout out some normal, like it spout out an integer, but it'd just be giant. And I was wondering if there's any way to just, like, if I type in a string, or if I just click enter, to just only to not give me an integer, so that I know how to handle it.
Yeah, scanf and sscanf actually return information that will tell us whether or not it succeeded in parsing whatever we ask it to parse. And we're always going to want to use that to know whether the integer, for example, that it gave us is actually, something the user typed in, or if it's just, random stuff that happens to be in memory. So we'll see how to use the return value from calls to sscanf.
All right, cool. Thank you.
Cool, you're welcome. All right, yeah, go ahead and send me attendance ping. And so let's start with ARGC and ARGV. And when you make a main program in C, you sometimes just do main paren, and that's saying I'm just going to run this program. I'm not going to pass any information on the command line. But if you want to be able to pass command line arguments, and remember these are arguments you put on the same line where you type the name of the program that you're going to run, right? So command line inputs as opposed to runtime inputs. We do main and we pass two arguments. We pass an integer and we pass a car star star. And then we write our main program. So with functions, right, main's a function. With functions, we can call arguments whatever we want. We could call, this Bob, and we could call this Betty. But the sort of standard conventional names are, we call this first argument ARGC, and we call the second argument ARGV. So arguments to a function. Argument is just another word for the things that you pass to a function. So we'll use the word argument a lot. It's an input to a function. Let's see. Question: if we're doing the SLP with a group, do we each work on our own proposal and submit it, or we work on one and submit copies of it? Let me double check and see what I said in Canvas, because I don't want to go against Canvas rules.
That was also my question too.
Okay. So let's see. SLP proposal. Submissions must be typed. One-page submission. Instructions should be here. It may be that I didn't say in here.
15 ODPs, huh?
They start with 4 for CSE224. And then for 222, they start with 2. All right, looks like I did not specify. Cool, so I get to make it up now. So I definitely want an entry from each person submitted, but you can submit the same proposal if it's a group. If there's 3 of you, you can all turn in identical PDFs. Just make sure that everybody submits one, so that when I go to Canvas, I actually see, you know, a PDF submission for your name. Make sense? All right. Yeah, don't forget about the SLP. All right. So a pair of arguments to main, right? And these are traditionally called ARGC, ARGV, while ARG is just short for argument. So C is short for count, and V is short for vector. Well, what's a vector? Think physics. It's well, don't think physics. Think programming. Vector is a collection of things. It's a good question why it's called vector. So this is how many arguments we have, and this is the actual collection of arguments. All right. So and these are the 2 things you need to know. So for example, suppose your main program is called, you know, blah.c, and you compile it to an executable called blah. So when you run it, you might say, you know, blah testing 25 haha. All right. So if you run your program and you put 3 arguments, testing 25 and ha, ARGC should tell you how many arguments you have. And then ARGV should give you access to those arguments. ARGV is an array. So you can always try sample code. So let's write blah.c. All right, this is classic code. When you're trying to figure something out, write yourself a little program to play with it, right? So I'm going to make a main program, I'm putting my arguments ARGC, ARGV, and all I'm doing in this program is I'm printing out the value of ARGC. All right, this should give me some information about just what the heck ARGC is. So I'll compile this, and I guess it wants an int. All right, so what am I gonna do? I'm gonna do blah testing 25 haha. So blah testing 25 haha, and it says argc is equal to 4. Well, you know, I specified 3 arguments here, but if I look at this whole command line, 1, 2, 3, 4. There's 4 things on the command line. That's what ARGC is telling me. So if I just say blah, ARGC is 1. If I say blah hello, ARGC is 2. If I say blah, you know, A, B, C, D, E, F, G, ARGC is going to be 1, 2, 3, 4, 5, 6, 7, 8 things on the command line. Okay, that's all there is to ARGC. There's nothing else that we need to say about it. It's the number of things separated by spaces on the command line. And since it includes the program name, the smallest value we'll ever see is 1. Which means that we type the name of the program but no arguments after it. Alright, so questions about this. Because there's always lots of questions, but they usually come up later.
So how can we utilize this for ODP 408?
This doesn't help us with 408 yet. So we got to get into ARGV next to be able to deal with the arguments.
Can you go back to this
script real quick? Okay, thanks.
All right. So we say blah testing 25 haha argc is equal to 4. That tells us that argv contains 4 things. Guess what argv contains? Blah testing 25 haha. All right. And if an array in C contains 4 things, how do we get to those 4 things? We say, you know, argv bracket 0, bracket 1, bracket 2, bracket 3. And that's all there is to argv. It's just an array of strings. Argv bracket 0 is a string containing blah. Argv bracket 1 is a string containing testing. Argv bracket 2 is a string containing a 2 followed by a 5. Right? So these arguments are always strings, even if it looks like a number. It's a set of characters with a null terminator at the end. And we can get to, you know, this argument by saying, give me argv bracket 0, 1, 2. We can get to this one by saying argv 0, 1, 2, 3. So let's use that in our code. Alright, so more test code. I'm going to do for I equals 0, I less than argc. And I'm just going to print out argument, and instead of %d, I'll print out I is, and instead of %s, I'll print out argv bracket I. So if I do this, it tells me argc is 8, and here's the value of each element in that argv array. Up to and including argument 7 is angle bracket G.
And so, does this also need to be an ASCII file or a .c file?
This file here?
Sorry, for 408.
408's a C program.
Well, I'm just wondering about the file extension, whether it needs to be an ASCII file or a .c file, because all the bash programs, I haven't been able to get them to work with the .sh or any other extension. It has to be an ASCII file. So I'm just asking now before I start doing it.
So with bash files, you can call them whatever you want, but you need that $! exclamation mark /bin/bash in the top. If you don't have that and you put a .sh extension, then it won't assess properly in some cases. But the extension really doesn't matter. But for C programs, the source code is going to have a .c extension. The executable is probably not going to have any extension. It could be a.out, but it doesn't really matter. But when you assess, you're going to assess, and then the name of the executable, and then the name of the source file.
Okay, thank you.
Yeah, welcome. So how many people are getting lag on their end from the screen share?
I always get it.
Not me.
Getting a lot of lag from that ENGR server.
Interesting. So I've been having like really pokey internet for about 16 hours now, and I kind of thought it was me, but if it's the ENGR server, that's not me. And Canvas was being really laggy last night for me.
Yeah,
I noticed the server was very slow yesterday.
there was apparently like a 6 hour like outage of service for like Instagram and Facebook.
Really?
Yesterday.
Interesting.
Oh, I wonder if that's related at all.
Yeah, I'm guessing there's something going on.
Oh yeah, I just had my internet cut out yesterday and also Saturday.
And this morning, when I tried to push something to get from Buddy on my laptop, it just it instead of like bringing out like lines like blah blah blah, it just stayed blank. So I took Control C and then try it again on my desktop, and that worked
Okay.
fine.
Interesting. So Verizon and T-Mobile were apparently down yesterday. Interesting.
I wonder if it could be another cyber attack like what Microsoft had a while back.
Apparently, stuff got deleted.
Apparently what?
Apparently, a bunch of like router
Oh,
something or other got deleted.
that's always
That's
good.
all.
Yeah.
And so they had to like remake them all, which apparently is a lot of work.
Mm-hmm. Yeah, the whole thing is shockingly fragile when you really come down to it.
They need a chaos monkey.
Yeah, right. And here's superstorm, solar superstorm could prompt internet apocalypse. That's a news headline from a reputable source, not really.
The Onion.
All right. All right. Well, if the video is laggy, the recording should be stable because I'm not having lag over here, so we can always go back to that.
I have a question about ARGV.
Okay. Cool.
We used ARGV on one of the extra credit assignments in our C class,
Mm-hmm.
like auto turning in our assignments.
Okay.
But I haven't used it for things like integers, and I'm trying to test it alongside you here, and it's implicitly casting from like a character to an int
Mm-hmm.
every time. Is there something special I need to do for integers?
Yeah. So we're gonna do that next.
Okay.
So that's where sscanf is gonna come in. All right. So ARGC is the number of arguments. ARGV is an array of those arguments. And this should be pretty clear, but I'm going to put this in uppercase. In uppercase letters. Never use ARGV without checking ARGC first. That should be ARGC, not ARGV. That one, right? If you don't know how big this array is, how do you know how many elements are in it, right? If you don't look at ARGC and you just start using elements from ARGV, how do you know those elements exist? And I guarantee at some point, some of you will write code that will try to do something with ARGV bracket 3 without checking to see if ARGC is at least 4, right? If ARGC is 1, then all you've got is blah. And these things don't exist, which means there is no ARGV bracket 1, bracket 2, bracket 3. And if you try to do something with those, you'll probably get seg faults, right? Your program will give up. So we always, before we use ARGV bracket n, make sure that ARGC is big enough that there is an element n in our array. So we don't have to do this for ODP 408. 408, you can assume that I'm always giving you an argument to your function, and so there'll always be one thing right here. But in general, if you didn't know if the person was putting an argument on their command line or not, right, we wouldn't want to just start doing something with argv bracket 1, seeing if it's equal to testing and so on, unless we first check argc and make sure argc is at least 2, meaning that we've got 2 things on there. All right, so let's play with sscanf. So sscanf is a way that we can take a string, like, a 2 followed by a 5, and change it into something like an integer. So let's make a new function. We'll call it dub for double. And so this is going to be a command I can run from the command line, and I can say dub space 25 and it should print out 50. And if I say dub space -5, it should print out -10. So it's going to multiply whatever argument I give it by 2. Okay. So I'm going to not bother printing this out yet. Say what?
You deleted the entire line in like an instant?
DD will delete a line.
Ah.
Yeah.
Very cool.
Which is nicer than like having to backspace a bunch of times.
I'm not really
You have to-
a fan, so.
You have to not be in insert mode.
You have to not be in insert mode.
Okay.
Alright, so I'm going to write this function dub. If I say dub 5, it should print 10. If I say dub 7, it should print 14, and so on. Alright, so pretty minimalist function. So how do we do this? Well, we need to get a hold of this argument, right? And remember, when we look at argc, argv, right, argv element 0 will be dub, and argv element 1 will be this number that we typed. And argc should be equal to 2. So instead of printing argc up here, I'm going to do something else. I'm going to say if argc is not equal to 2, I'm going to print out an error message and say you need to say dub followed by a number. And then I'm just going to return. All right. Otherwise, I'm going to print the arguments. Well, let's get this working first. So if I say dub 5, presumably it's going to go on and it's going to run, whatever code I put here to print 2 times that number. But if I just say dub, it says error, you need to say dub followed by a number. And if I say dub 510, it's going to say error, you need to say dub followed by, 1 number. And if I say dub followed by 1 number, then I don't get an error message. So you can make sure that the user is giving you the proper number of arguments by checking argc.
I got a question.
Yeah.
Could you remind us, who have not used C in a little while, what putting a 0 in parentheses after return does?
That's just setting it up so that if I look at the status from this, it gives me a 0. There's no reason for that, but if I just say return,
Well, what's the difference between
I think it will give me a compile error.
What's the difference between doing a return parentheses 0 and just a return space 0?
There's no difference.
Oh, okay.
So if I want to just return, I can make this function void, but I was trying to avoid saying void just because it's not quite as common. Oh, and I lost this. All right. So we'll just make this function void so it doesn't return anything. So I can just say return. All right, so if ARGC is equal to 2, then we know that we have a number here, and that number is in ARGV bracket 1. Now, if I want to print that number, I could do the following. Right, and that's going to print the argument that the person specified. So if I say dub 77, it's going to print out 77. But if I want to print 2 times that argument, I have to do something special. So I can't do this. Right? And if I try to compile this, I'll get an error. And the reason is that ARGV bracket 1 is what we call a string. It's a set of characters. And there's no operation defined for multiplying a set of characters by an integer. It's not a thing. So before we can multiply this argument by 2, we have to change it into an integer. And that's what sscanf does for us. So sscanf takes the following form. So we say sscanf, we have some string. And then we have something like what we put in printf, something that tells us about the string. In this case, we're expecting the string just to be an integer. So we can say %d, which says, hey, I'm expecting the string to begin with an integer. And then, just like printf, we list variables over here, but this time we actually list the address of our variables. So I'm going to say, address of num, where I've declared, num to be an integer. And what this will do is it will look in this string, this collection of characters. It will hopefully find an integer in there. And it will take the integer value of that string and store it in this variable called num. All right. So let's do that. And then what I'm going to do is, as an integer, %d, I'm going to print 2 times num. Alright, so this is just declaring an integer. This is saying argv bracket 1. That's that first argument I put after the word dub. Let's interpret that as an integer. And if we can convert it to an integer value, let's save that value in this variable num, which is an int. And then my print statement, I'm going to take that number, multiply by 2, and print that out with a %d. All right, this is only 2 lines of code, but this is a lot of stuff going on, and it's a lot of stuff that we can get confused about. And that if we know how to do these things, it opens up this huge world of possibilities. Right? So it's a short segment of code, but this has got universes of opportunity and strife inside. So think about these two, and let's have a lot of conversation around any uncertainties about it. But let's see what it does. So if I say dub and I say 77, hey, it prints 154. And if I say dub 2, it prints 2 times 2 is 4. So this apparently works, right? So questions up to here. And we've got a lot more to say, but I want to keep everybody on the same page as we're going through this.
Go back to Leave the script for a second.
Go back to the what?
For a second.
Over here? Or over here?
Yeah, there.
Okay.
Okay. So it reads the value that you put in, and then ARGC says, okay, look, there's one value, so it sets that to 1, and then it stores that value into ARGV in the first slot. That was because there's only one slot because ARGC set it to just 1.
So if ARGC is 1, then ARGV only contains one thing, which is the name of the program. Thank you. If ARGC is 2, then ARGV contains 2 things. The first thing is the name of the program. The second thing is the actual argument.
Okay.
So it's always kind of off by 1. And it counts differently from bash, so that's extra confusing.
Okay. That makes sense.
Okay. And there's a limit to how big integers can be. So depending on what you put in, right, you might not get 2 times that, because integers can only go up to about 2 billion. So things get truncated. That's okay. We're not usually going to worry about that. But this works with 0. It works with, negative numbers and so on and so forth. And this works because scanf is a really super duper function. It can understand all kinds of strings here and interpret them as integers. It will also do the following. I've got one argument, 25, ha ha ha. Well, it's going to scan this. It's going to pick up the 2 and the 5, and then when it gets to the h, it's going to say, oh, that's not part of an integer. But it's still going to take that 25 and convert that to an integer, store it in num, and then print 2 times num. So scanf is pretty adaptable to what it sees. This also means that if I say something like, double 1.3, scanf is only going to see the 1, it's going to double that and give me 2. It's going to basically ignore this 0.3. And that's okay for now, too.
So when you use GCC, it created the executable file.
Mm-hmm.
And dub is you're just calling the executable file because it's already compiled.
Right.
Okay.
Yeah, so when you say GCC, that creates this executable dub. And if you tried to run the C program, you'd get a message saying permission denied. But when you compile, dub is automatically made executable, and so you can run it.
That makes sense.
Cool. All right. So what happens if I don't put a command line argument? Right? I get this error message saying error, need to say dub num. But suppose you don't do that. Suppose that you're writing this really quick and dirty, and you don't bother checking to see what ARGC is. And I just say dub, I get a segmentation fault. Now, why am I getting a segmentation fault? Because I'm saying I want to do something with ARGV bracket 1, but if you just say dub, ARGC is 1, which means you have an ARGV bracket 0. You don't have an ARGV bracket 1. And avoiding that seg fault is really easy. If I'm going to use ARGV bracket 1, make sure ARGC is at least 2. If ARGC is less than 2, I'm almost guaranteed this is going to give me a seg fault. Okay? This is the way to check if you have the proper number of arguments. You don't check it by seeing if argv1 is null. You don't check it by calling scanf on argv1. You don't do anything with argv1 unless you know argc is at least 2. This is the way that you check to see how many arguments you have.
It's almost like protecting yourself against the null pointer.
Mm-hmm. Exactly. And this is just an int. It's pretty harmless to work with, right? It could be 1, could be 15, could be something else. It's just a number. It's an integer. You can compare it to other integers. You can put it in if statements and so on and so forth. Do that before you start working with this. These things are weird. These could be strings. They could be nulls. They could be something really strange. All right, so what if you do something like dub haha and give it something that's not a number? Well, you get a weird answer back. So 2 times haha is 65,530, or 65,532, or 65,528. So this is not good, right? If someone says double haha, you not only give them an integer back, but you give them back what looks like kind of a random integer. All right, so we want to know if sscanf succeeded in converting an integer or not. Whatever I give in my string here, it will try to convert that as an integer and store the result in num. But how do I know if it actually succeeded? If there's a possibility that string contains something like haha instead of an integer, how do I know what sscanf did? So it always returns an integer as the function value. Now this integer is fundamentally different from that integer. The things I list here, these are the things that sscanf is doing. It's going through the string, it's looking for things that match this pattern, and anytime something matches, it stores the value in the next variable. But this return value, the value of the whole function itself, result in this case, this tells me sort of the status of what happened, right? What kind of day did sscanf have? And this result is always the number of things converted. This tells me the number of things that sscanf converted and stored into variables. So if I'm asking it to convert, one integer and store it in one integer variable, if that works, sscanf should return a 1. All right, so here's how we're going to avoid this funny business of, trying to double haha. So, and let me put this back in here because this was nice code. So I'm going to do integer result equals okay, so if result is not equal to 1, so this means sscanf couldn't change string into an int. I'm not going to worry about my typos anymore. So if result is not equal to 1, what should we do? Let's printf error %s is not an integer. And I'll just return. All right, so I'll call scanf, same as we've been doing, but I'll check the return value from that function. If it's anything other than 1, then it did not manage to convert my string into an integer and store it here. So I'm not going to use the value of num because I don't know what it is. I'm just going to print a message and say error, and I'll actually print out, the argument in argv bracket 1, and I'll say blah is not an integer. And I'll return. If I don't return, that means that sscanf gave me back a 1, which means it succeeded in converting my string to an integer, and it stored that integer in num, and so now I'll print 2 times num, and everything should work. So now if I say dub with no arguments, it yells at me again. If I say dub3, it doubles it. If I say dub haha, it says error, haha is not an integer. And so now I've got really solid code. This will not, throw a segmentation fault on me. It will not give me a random number because I typed something wrong. It will insist that I type an integer, and it will show me twice that integer. And this is the way you want to check to see if it converted one thing. Don't check to see if it's equal to 0, because it's not always equal to 0 if something goes wrong. Sometimes it's equal to -1. But if you're using scanf to convert one thing, save the return value, see if that's equal to 1. If you use scanf to convert 5 things, save the return value, see if that value is equal to 5. Right, however many things you're trying to get scanf to convert, make sure that scanf returns that same number. And if it returns anything other than that number, something went wrong. And you can act accordingly. All right, questions on this? So let's do a floating point version. Let's make num a double. And if I do this, if I just change num to be a double, I'll at least get some warnings, I think. But I can still compile and run with warnings. But if I do dub F2, I get unexpected results. Is my screen frozen? Dang.
It's just extremely lag.
Okay. Let me, I don't know if it'll help. Let me kill my camera there. I'm going to reboot my machine before the next class. Maybe that will help on my end. All right. So to make this work with doubles, I'm going to change num to be a double, but I can't use %d to scan a double. I have to use %, and I'm going to do lf. And this is what the ODP tells you to use. So I'll do lf down here. And now if I do dub f222, I get a floating point 444.000. And if I do dub 3.14, I get dub 6.28. All right, other questions about this? All right, so ODP 408, you're going to write a program similar to what we just did with dub, right? But your program's going to print the square root of its argument. All right, so you've got to compile this on linuxengrcs.com with default options, and when you compile, you need to do a -lm after the GCC. So you're going to do something like GCC-O ODP 408 ODP 408.c space -lm. And in the beginning of your C program, you need to include angle bracket math.h. So those are two things because we're using square roots. So you got to include math.h, and you've got to put the -lm switch. All right, and make your variables doubles. You can assume a single command line argument is given, so you don't have to check ARGC. You can, but I won't test it with ARGC other than 2. And you can assume that it's not a negative number, so you don't have to test for, you know, trying to take the square root of a negative. So no error conditions to worry about. Just take the first command line argument, scan it with a %lf into a double, calculate its square root with square root, and then print it with %lf. And as usual, the only output should be that square root. You can't say the square root is number, right? So this should run like this. If S1 is your program, you should take your program, put a number after it. It should just print the square root. And as long as you output with %lf \n, the format of this should be correct. Should be what SS is looking for. So that's ODP 408 due tomorrow at 10. And then tomorrow's ODP, we're going to add a bunch of error checking to something that processes arguments.
Can you show your what program you did?
This one? I'll push these over to the server in the shared code area too.
Where's that? How do I access that?
There's a link on Canvas.
Okay.
All right. Any other questions?
So just to reiterate, the scanf that we added afterward, check to make sure that the number, the argument 1, the number that we passed to it just returns one number value.
Mm-hmm.
Right?
Yeah.
Okay. Cool.
All right. Send me a parting attendance ping. I'm going to end like 2 minutes early so I have time to reboot and see if I can get some things reset on my end. Which means the video upload will happen a little later today, but I'll do that after the second class, along with pushing this code over to the Linux server. And hopefully the network will survive. Is that a question?
Have a good day.
All right, thanks. You too.
Good day.
All right.
Have a good day. Good night.
See you later.
Look at what?